simple style. I'm going to do a little intro roll, but let's just pretend like we're the only people. There's probably nobody going to join in to watch anyway. So we should.
Not hopeful. Maybe someone might join.
Well, no, it'd be great if somebody joins. I'm just saying, like, you know, the online is secondary anyway, and since there's so few of us tonight, let's just do whatever it is that we want to do. So, but as you know, official business. So sad news is I'm considering dissolving Stack.js because over the last few months we've had lower and lower attendance, and I personally am not as enthusiastic about JavaScript as I once was. So I might reach out to the mailing list and kind of see what happens there. But, so official news out of the way. More importantly, thanks again to Vivint for hosting us and providing the pizza, and to Travis for reaching out to get the pizza physically and bring it to this location for us, and to supervise us and be our chaperone so that we can be allowed to meet here. And earlier we were talking about, we were just chit-chatting about different things, and we were talking about JavaScript with types again. I did this presentation recently, so I don't want to do the presentation again, but we'll just kind of go through an example together, and I will show it, and then I might flip through some of the slides to make sure I don't miss anything. But that's what I'm thinking about. And then I'm just going to do one little thing here, if I can just get the chat to come up. So that, let's see, restream chat. There we go. I just want to get the chat up on this so that if somebody does have any questions or want to ask something, that we've got that available for me to open. And the funny thing is, because of the lag between the TV, I am actually going to be looking, I'm going to be looking at OBS as I record and using that as my screen, because this drives me bonkers, the lag that is on the TV, and I just can't work with it. Okay, so here's the deal. JavaScript has types. JavaScript has always had types. Okay, I actually will go through a little bit of the presentation here. So this is what we're going to do. So I created a tool called JSWT, stands for JavaScript types, and it just automates some of the tedious stuff like getting your jsconfig.json set up right. I have been told, I have not validated this yet because, you know, it takes some time to go through and try new configs, but I've been told that basically with the latest version of TypeScript and the latest version of the jsconfig.json, I can actually trim down a ton of stuff and make it much simpler. I don't know, I haven't validated that myself. Also, VS Code treats your project differently than TSC does. So TSC is the utility that actually does the type checking. Mm-hmm. And VS Code has a built-in version of TSC, and it has different defaults than when you initialize in a project. And since I primarily work with them, I don't know. I'm not sure. So anyway, so we'll get to that. But let me go to a couple of things here. So we'll go through a couple of things in the slide. First of all, I think this is actually important. This is not a gateway drug to TypeScript. JS with types is getting types in your JavaScript and getting the benefits of types, but not having the drawbacks of TypeScript. I don't like TypeScript. I don't like the type system of TypeScript. I think that JavaScript has a much better type system if used effectively. And I'm not going to go through that slide again. But build steps are not good. Slow build steps are straight up evil. And code gen is better than metaprogramming. I think that's really important, and that's where TypeScript just falls off the rails. Is, you know, you recently saw that demo with Doom, I assume.
Yeah, I believe so.
So there's been first Flappy Bird was implemented in TypeScript types, not in TypeScript, but in the TypeScript type system, because the TypeScript type system is a language and it is Turing complete. So you can do recursion and loops and all this stuff. So anyway, and so somebody created a custom LLVM compiler for the TypeScript type system language and wrote Doom, well, transpiled, well, I guess LLVM JIT code, I don't know. Used a compiler to do Doom with LLVM and the TypeScript types. I don't know what manner it was. I don't think he rewrote it because it probably would have been much faster. I think that he used LLVM as a language transpiler, which I don't know if you're familiar with LLVM. But anyway, Duck typing is good. That's what we get in JavaScript. Inheritance is evil. Duck typing is what we get in JavaScript. Inheritance is what there's a lot of focus on in TypeScript. So I don't believe that. Better tooling makes better developers. This is good. So this is and then the point that I wanted to get to that was here was, let's see, types are in the tooling. Types are in the tooling. So in every language, no matter whether it's Go or it's C or it's TypeScript, the types only exist in the tooling. The CPU does not know the types. The CPU just has bits and it has registers and stuff goes in the registers and operations gets performed and it doesn't know if it's a movie or if it's a text file for the most part. I mean, there are movie-specific encoder, decoder chips, whatever. But the point is that at the layer that it starts loading into the CPU, it doesn't know what it is. So if there's any, and there was recently a problem with the Rust type system where it was possible to have bad code because their compiler was messed up. So if the tools aren't working correctly and identifying problems for you, then it doesn't matter what the language is, whether it's statically typed or whatever. Because while you get performance from static typing, the performance is not the benefit to the developer. That's the benefit to the end user. Well, sometimes the developer, because it's nice when we don't have to wait 15 minutes for something to deploy or whatever. But yeah, and JavaScript's always had types, and it's duck typed. And like I just said, static types are a lie. So let's just go over real quick this, and So there's basically types of types, right? So there's single value types, there's multi-value types, there are collections, and there are meta types. So real quick to go through this, and then I think we'll just go straight into actually setting up a project. So you've got your primitives, which are pretty much these things. So Booleans, true, false. Boolean is a type, number is a type. Now number in JavaScript is actually more than one type. Numbers are kind of complicated in JavaScript, especially as the language has evolved and more number types have been added. But JavaScript does in fact have 32-bit ints that can be enforced by the code. And the way to do that is the triple shift operator. So you triple shift to 0, it enforces that the thing that you're working with becomes a 32-bit int. uint specifically, uint, a 32-bit uint. If you do any bitwise operations, the number becomes a 32-bit int. But if you use the triple shift, it becomes a 32-bit uint. So if you want something to be a 32-bit int, all you have to do is something like mod 1 or double shift 0. Double shift 0 is probably the more canonical no-op for that. And if you want it to be a uint 32, you triple shift 0. And I actually learned this very early on because I kid you not, I tried to write a driver for a video capture device in JavaScript. It didn't end up working, but it was because the Linux kernel didn't have support for it properly. It was documented one way and implemented another way, and things got worked out. But wouldn't recommend it, but can be done. Strings. So these one interesting thing about this is the implementation of this is UCS2, which means that strings in JavaScript are 2 bytes wide. Well, each character is 2 bytes wide, and then they have UTF-F on top of it. But if you do something, there's a number of operations that if you perform on a string, what you will get is weird. The counts will be off. You have to use text encoder to get the right results. So if you ever need to work with strings, like for example a password that has Unicode in it, or a password that's Chinese characters or something like that, you want to be using text encoder. Big int, so that is a recent addition, but it's an absolutely necessary one. These are arbitrary sized integers. And in their smallest form, I may be mistaken, I believe that they are implemented as int64. So obviously they're arbitrary size, so if you go beyond an int64, then it becomes an arbitrary integer. But my understanding is that the implementation of a big int, when it is within 64 bits, is that it is a 64-bit integer. And you can do big int bitwise operations, which would lead me to believe, although I have not confirmed this, that you could use the double shift and triple shift tricks to get 64-bit ints and uints. Then we got the function. We got things that are null-ish, and null-ish is weird because we have null, undefined, and not defined. So these are our primitive types in JavaScript, and then there's also kind of, sort of in here. We have the byte array. So you've got your uint8 array, uint16 array, uint32 array. And then I think it's a uint64 array, which takes big ints, if I remember correctly. Or, yeah. But anyway, so you got that. But then let's talk about our typical multi-value. And these were actually in the wrong place, so forgive that. But we have struct and tuple. So struct and tuple are conceptual. They're not something that there is specific syntax for in JavaScript. They are optimized that way, or at least struct is. So struct is anytime you're using curly braces and you're reusing a pattern. So if you have a function that returns, you have curly braces in the syntax, and you return name, age, and phone number from that function, then that will, under the hood, that will create a struct. And so you will get the benefits of performance of having a struct on that, provided that you don't do anything weird to it. So when the code is analyzed, this is not part of the spec, but this is the way that it's actually implemented in the various engines. When the code is analyzed, where things are consistent and not loosey-goosey, types will be developed for them. Now the tuple is when you, so struct is when you have something like name, age, phone number in an object, in a curly braces object. So a tuple would be when you have different types of things, but a set number in square braces. So anywhere where you're always returning, say, square braces, and you put in AJ 38, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If that's the format that you're returning from that, then that's going to optimize as a tuple. I'm not 100% sure that that will actually optimize as a tuple, so I shouldn't say that. I have reason to believe it will optimize as a tuple because structs optimize as structs, and structs and tuples are basically only different at the syntax layer. They're not different at the implementation layer. So Zig actually does a really beautiful, has a beautiful example of this, because you can, if you have an anonymous struct, it's a tuple, or anonymous. If you have a struct where you don't define the keys, it's a tuple. So tuple just means that it's a list, but it's not like a list of numbers, it's a list of things. So structs and tuples are the same, except structs are key value and tuples are position. So the index into a tuple is 0, 1, 2, 3, just like an index into a list. An index into a struct is name, age, phone number.
So then one follows a index type structure, then the other follows like a field type of structure is what you're saying?
Yeah, exactly. Exactly. And when these are optimized, they're the same.
Okay. So they fall under the same thing, just the way you write it.
Yeah, it's just syntactically for the developer, they're different. But when you look at the way that these are in when things get compiled or JITted, they are typically going to be represented the same, because you're not actually accessing that thing. You're accessing it by a pointer reference. And so the pointer reference on the struct is wherever you have name, that's pointer reference is 0. Wherever you have age, pointer reference is, well, a string is a box type, so maybe it's going to be 2 bytes away, or maybe it's going to be 4 bytes away, or maybe it's going to be 8 bytes away, but it's going to be some number of bytes away. So when you use name, it's just going to be, or when you use age, it's just going to be name plus the number of bytes to get to the next field in the struct. But that's exactly what it's doing when you use a tuple, is that the 0, 1, and 2 just get replaced with the pointers to the data, or the offset to the data. So those again, they're not specified in JavaScript. They're just understood by the JITs. So then the other type of multi-value is that we have map. And again, these were a mistake. They were supposed to be over here, but I still haven't fixed that. So map is where you have something where you do not have consistent names. So you might have a consistent width, like maybe you have a hash value, and the hash value is the user ID, and it maps to a user object that has name, age, and phone number. But the map is something where essentially the way that you define a map in JavaScript is if you can't optimize it into a struct. If you can't optimize it into a struct, it's a map. And then they do have these weak map and weak set and map and set and some of that stuff, which I can understand where weak map and weak set might be valuable, but in general, I like things to be JSON. I like things to be friendly on the network layer, unless I've got a really critical reason to use one of those. I've never used them. I've never come across the case where I needed to do the memory management to use weak map or weak set. I have used weak timeouts because particularly in Node, if you don't want your server to hang forever, you need to do weak timeouts and weak listeners. Unreferenced. They're called unreferenced. They're not called weak. They're called unreferenced timeouts and unreferenced listeners, which will allow the server to shut down. It's like, say you have a ticker that's going, but all the other processes are done. The only thing that's keeping alive is a ticker that's going to do nothing. Then if you make that ticker an unreferenced interval, then the event loop won't count against it from letting the process die. That doesn't matter in the browser, but that's the only place I've used that sort of thing. I know that there are use cases for it, particularly I believe in gaming, you would find some use cases for that. But a lot of these things, if you want to optimize, you can just do what you do in a compiled language. You just pre-allocate a bigger array, put everything in there, reuse objects, like take the same object, just change the name, age, and number value rather than creating a new object. Some of that's going to get optimized by the JIT compiler anyway, but you can force it to do that by just reusing objects. Keep a pool of objects just the same way that you would do in Go or C# or whatever. Allocate the memory, keep the pool of objects, put their values in there, and then recycle them when you need to use them again. So that's not what I meant to talk about. I didn't mean this to be a performance talk, but or discussion. I don't actually mean this to be a talk, but I've got the camera on, so it feels that way sometimes. Anyway, and then list. I don't like using the term array in JavaScript because array actually has a specific meaning, and JavaScript does not have arrays. It has lists. It does have uint8 arrays. Those are, to my knowledge, those are arrays. But the things that that have the syntax with the word array are actually lists. They're not arrays. And because arrays have a fixed size, that's the whole thing about array, is you allocate an array to a fixed size. Now, when you have a list, one of the benefits of a list is as you add to the list, it's going to dynamically allocate and resize typically, and you know that from your Java experience. That's actually really good.
That's what actually we're writing with their dynamic array. So every list pretty much.
Yeah. So, and then, the list is different from the tuple because in the list, all of the values ideally are the same type of value, and so they're being indexed at the same rate. And this is where the plus comes from in the C syntax, is that you're iterating the pointer to the next element in the array. The plus is not increment by 1, it's increment by 1 pointer. It's increment by 1 width of the byte size in objects. So that's all stuff that pretty much exists in every language. And then some of the newfangled things that exist in the new languages that are purely syntactic are new types. And apparently, I believe that TypeScript actually has new types, but I don't think they can be represented in JavaScript. I'm not sure. I got to talk with somebody who was trying to tell me a little bit about this. And I wasn't able to dig in with them at that time, but I said I wanted to learn more, so I just haven't yet. But new types mean that you take a type and then you give it a new value, and the type checker, whatever language it's in, will check that type. So for example, great example, dollars and cents, or metric and imperial. So I have feet and I have meters. I would actually, if I needed to do feet and meters in my program, I am going to new type int as foot, and I'm gonna, or feet, and I'm gonna new type int as meter or meters. And then I am going to declare a value not as an int, but as meters. And then if I try to multiply meters by foot, I will get a type error. It will say types are incompatible, meters and feet. The underlying type is an int, but the type checker will be told these integers are incompatible. And so if you want to pass it as an int, you have to explicitly cast it and say, I know that I'm losing the reference to this as meters, and I'm okay with that. And then type aliases are what we call marker types, which means that, and this is what you typically are doing in JSDoc, and I'll show this. But marker types are where you are just using it for documentation. So for example, I do this. I do hex string and base 64 string, base 64 URL string, base 58 string, base 32 string. So I will retype string as a type alias for documentation purposes. So when you get the type hinting, it will pop up and it'll say, really important if you have to deal with both base 64 and base 58 in the same program, because syntactically you cannot tell the difference between them. Yeah, so it'll give a hint. It'll just pop up and say this expects a hex string, because string, like my name is a string, but it's not valid hex. Now you're not getting the enforcement on that from it, either in the checking or in the validation. That would have to be done. In the case of JavaScript, that has to be done at runtime. But marker types are valuable nonetheless. Then you can also have value enums, which can take two forms. One is, you've got the C-style enum where you start at 0 and you go 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can have enums like that. I don't really use them in that way, but what I do use is enums where I'm using a string value. So I'll say type of unit of measure. So I'll create a unit of measure type, and it will be a string, and it will have metric and imperial. And so then if I try to pass in the string bananas into a function that accepts a unit of measure type, then I'll get a type error. I have to pass in either the exact string metric or the exact string imperial. Of course, this is not optimized, and the reason that other languages have the syntax that they do is they optimize the strings away, and then same thing that I was talking about with the struct and the tuple earlier. And then we have type enums. Type enums or algebraic types are where you're saying this type can be this or that. So this can be a cat or a dog or a person. It can be any of these types. So I will, and you can pass any of these in. I will accept any of them. And then that actually goes into interfaces, which I don't think I put on here, but you can have interface types, which are duck types. So you could say speak. Anything that has, or name, like anything that has the property name. I typically use it more with values in JavaScript than with functions. But anything that has the property name is a named entity. That's the type. And so the named entity type will just be an object that has the property name that's a string. So then I can pass in dog or bird or cat or human, and the types work. Then we have mix-ins, unions, which is where you can take types and say, I'm going to take all the types of, all the properties of dog and all the properties of cat, and I'm going to join them together, and I'm going to create a cat-dog object. That's a terrible example. I'm trying to remember what the example of that is. But, okay. The example that I give later in the slides is a complete person. So you have a person that has name, age, and phone number, and then you have a partial complete person that has a spouse. And then you can take, so you can, this is the way I do it. There's a type partial person, name, age, and phone number, and there's a partial complete person, and it has a spouse. And so we can do type complete person is partial person with partial complete person, and that creates the type complete person that has the properties from both types. I actually use that a lot with, you know how in database CRUD operations, it's like, okay, well, if I'm doing the post, the create, I need to include the ID, but if I'm just fetching it, then I don't need to include the ID. The ID is optional in the query and stuff like that. So I often just rewrite the types out depending on how similar or different they are. But depending on how similar or different they are, I'll either rewrite the types out, or I'll take the common set and I'll make it, this is partial person, and then I'll say, like, this is partial create, and this is partial update, and then I'll just blend the types together as a mix-in, so that I can then not have to be excessive in specifying the same thing where it'd be difficult to tell. Like, this is kind of a litmus test. Is it more difficult to just look at the two things and see what they are, or is it more difficult to look at multiple things and see how they fit together? And in the case that I'm giving, like, if there's only 3 or 4 properties, I'm just going to duplicate it, because you can scan it and you can easily see without any question, without, assuming you alphabetize the properties, you're all good. You're going to see it. But where it gets to be long and it's like, okay, well, this person has 15 properties, that's where I would go for the mix-in approach and say, okay, let me take the 3 things that are different over here and the 2 things that are different over here, and I'm going to mix these together. And the common properties, then you don't confuse thinking like, wait, Let me go line by line. Are these the same? Like that's kind of my litmus test. That's how I figured that out. Then we have template types, which are basically, so there's this problem where when you, I just mentioned earlier, we have the named entity. So let's say that you need to, sort's a bad option because sort just happens in place. So sort would be a good reason why I would have a named entity. I want to sort things by their name. I'm going to have a sort function that's sort by name that takes a named entity. Then the problem occurs when I have a function that needs to operate on, let's say that we're using the name to create a hash value. That's how we're going to ID. We're not going to use the name as the ID, but we're going to hash the name to use it as an ID. That would be a case. I've got a better one, but it's probably in the slides. I just can't think of it off the top of my head. But anyway, so you got that case. Well, what happens is if you accept a named entity and then you return, it's going to return a named entity. So then when you go on the next line in your program, it's going to say, person doesn't have an age, like age property doesn't exist on person. It's like, well, it existed on person just a moment ago. So the template is where you say template type, it's T of type named entity, which means that anything that's a named entity can go in, but whatever the template value is what goes out. So when you return, it retains its value rather than losing its value. So that's where the template types come in. And then you got utility types like partial and I think it's required, partial, promised. Partial means that all of the fields become optional. So you get the type checking of you can't typo the spelling of a property. Like I couldn't put main instead of name. But if you don't specify the property, then you don't get a penalty. So that's what a partial is. And then required does the opposite. If there are any, and this is another thing I do with the thing I was telling you about before with the database types, whatever. So if I'm retrieving something from the database, the thing that I actually retrieve should have all of the properties on it. And so I can just throw a required on that, and then it says, okay, anything that was optional for the query is required in the actual returned object. I mean, that's not always the way that it would work with every table, because a lot of times you have null values in tables. But that's an example. And then promised, there's also type of and promised. Promised just means don't tell me that the type of this is a promise. I want the thing that's inside of the promise. So it unwraps the type for you from being a promise of a person to just a person. And then another utility type was type of, which is where when you have a function and the function, a lot of times it depends. I can't remember what my litmus test is for this, but there's times when you want to explicitly define what the function should return. And there's other times when you want to say, whatever I do in this function, calculate that and let that be the return value. The problem with that is if you don't specify the return value, you can't use that type in other places. But you can do type of return, and then that can give you the value of what a function returns. Or not the value, it can give you the type of what a function returns.
So kind of make it like more generic on whatever it returns type?
No, it makes it so you can use that type somewhere else. Okay. So let's say that it's just, I think in many cases it's more of a little quick hack because I don't want to go back and rewrite the type definition for the return right now. I just want to say whatever type it returns, give me that type, and I'm going to use that type as an input over here. Okay. So it's kind of a code smell, but there are situations I've found, especially there's been a couple cases where there's no circular dependencies in the JavaScript, but there are circular dependencies in the types, because the types get calculated a little bit different than your packages do. And so I've had problems where I've needed to use that to fix something that I didn't want to deal with in a more lengthy way at the time. So there's that. Anyway, so those are all of our types of types, and I'm not going to go through the slides on this probably, but we can just go over here, and I'm going to go ahead and we're going to make a new project. I'm actually going to go and attempt for this. I love to go and attempt for my makeshift projects. And we're going to create a new project, and we're going to call it, what should we call it?
Demo.
Demo. Excellent. Name of champions. Actually, this is going to be a package name, so we're going to use lowercase. Oh, wait. yeah, on Mac, since the case sensitivity is not like it is on Linux, you have to actually change the lexicographical name. Anyway, so yeah, so what I'm going to do is npx JSWT at 2. So this one works with ESM. When I originally did that presentation, I did it with CommonJS because ESM wasn't standardized yet. As of December 2024, ESM is finally a thing, meaning that you can use it without transpilation and it's supported in browsers and Node correctly. Unfortunately, there's still an edge case where it's not supported in TypeScript correctly, but what do you do? Yeah, like I said, it's an edge case. I don't think we're even going to go over it, but it'll rear its ugly head eventually. Oh yeah, so I have to do npm init first. That's one of the rules. So we have to do npm init first, and then once we've done npm init, we can do JSWT init. And 2 is the default version now, but I just to be clear, the 1 was CommonJS and 2 is ESM. So this is basically what it spits out for the jsconfig.json. So we can go over this real quick. This is kind of important. So these 3 are the first most important because they have to be set this way. And I looked it up and I went through, and I'm hoping that maybe this is one of the things that we can get rid of that doesn't need to be there anymore. But there's just some complexities because of the history of the TypeScript checker and how it started with regular JavaScript, and then they moved to Node, and then they moved to ESM. Actually, I think they moved to ESM and then moved back to Node, because I think they were working on transpiled code before they were working on untranspiled code. Yeah, because the JavaScript type checking got added later, which is one of the reasons that TypeScript doesn't actually support. Until version 5, TypeScript checker was not very good at JavaScript. In version 5, it got significantly better at understanding JavaScript types. So you could write JavaScript. But anyway, that's kind of what this has to do with. So target, module, and module resolution are pretty much all the same thing. But yeah, it has to be Node Next, even if you're doing it in the browser. It has to be Node Next, and I don't know why. I don't remember, but I looked this up just a few months ago because I was updating it for ESM and I was running into some problems, and I found a forum post and this person's like, oh, you got to set this, and oh, that doesn't work. Well, you got to set this. Well, these 2 have to be the same, and So anyway, this will set it correctly as of the current version in this year, 2025. And if in the future that becomes simpler, great. I'd love to modify the template. But that's one of those things where if you don't want to go through a bunch of forums and figure it out, it's nice to just have this generated for you. Likewise, the paths. This is where there's actually a little bit of incompatibility between the TypeScript and the Node, because TypeScript checker does not support the proper import syntax that's been defined for ESM. It doesn't support it. So that is a tool that's not going to affect you in a browser or in a runtime, but that does affect you in that you can't mix and match. The thing is, you can't mix and match relative paths with, I think it's, so like you can't mix and match something starting with a / and something starting with the name of the package. So basically with this, the package name is demo, so the paths need to start with demo too. So demo, and then here it says that demo is an alias of ./demo.js. And here it says demo/star is an alias of ./star. So one thing that I might change in this, depending on the project, is I might nest the bulk of my code under a lib folder. If I was going to do that, then I would probably update this to be ./lib/star. Then type roots, this we don't really have to worry about. This has seemed to be working well for me. So if you need to use TypeScript definitions, it needs to know where to look for your TypeScript definitions. And if you have custom ones, you would want it to be in ./typings. And the ones that you're getting from definitely typed, you would want to be in node modules at types. If the types can be expressed in JavaScript, and if the packages that you are importing express the types in a way that they are compatible with JavaScript, you wouldn't need this at all. However, the reality is that many people went and rewrote projects in TypeScript and then transpiled them back to JavaScript, and that resulted in types that are not compatible with JavaScript, and so you need to have the type definition files in order for those types to be understood. Now, personally, I have had some things where I've had a couple of workarounds, or I've had to add a @ts expect error, which tells it that, hey, I know that there's going to be a type error on the next line, and you're wrong, not me. But I just don't want to have the complexity of Turing complete types. So I say no to Turing complete types, and if I can't represent my type in JavaScript, then I try to simplify what I'm doing, if I can. But for the times that you can't, or for the times when you must use a third-party module, that's what you got to do. Allow.js and check.js are kind of what they sound like. Allow.js is saying this is a JavaScript project, and that's okay. And check.js is saying not only is it okay that it's a JavaScript project, I'd like you to check it for me. Then no omit means we don't want you to transpile this. ES module interop means it actually probably logically belongs up here with these. It's just one of those things to say, yeah, just treat JavaScript as JavaScript, please, okay, thanks. Force consistent case in file names. That is something that I strongly believe in. We should just use lowercase for file names, and the file names and the package names should be the same. This actually does matter on Linux. So if you ever have a problem where your type checker is passing on Windows or Mac and failing on Linux, it might be because you accidentally created a file with camel case or something like that, but then the type name doesn't match the file name. So for the sake of consistency, especially with ESM, because ESM is case sensitive. Now the implementation of it may not be in some circumstances, but it is. So your file name and your import name should match, except in the case that you are doing something like the package name, the import name, and the package and the import path should be consistent with one another. And that's part of what this paths thing does, and that's also in your package.json. So the downside is you do have to define your imports in 3 different places, in package.json, in index.html, and in jsconfig.json. We'll get to all that. And then no implicit any and strict are kind of the same thing. These are just always strict, no implicit. Yeah. And then skip libcheck, as far as I can tell, this doesn't work. So I've got another workaround for this that's actually in there. But the idea is, look, I want to check my types, and in as much as I can determine the types of a package that I'm using, I want to check the types of the package that I'm using. But I don't really care beyond the interface boundary. When I call the function, I want the type to be correct. But if I'm not calling the function, if they've got some internal implementation detail, I don't care. I don't want to know. However, the skip libcheck in practice doesn't work. TypeScript will give you errors for everything in your stack 1,000 layers deep of dependencies, and that's one of the reasons it gets wicked slow. But there's kind of a deal with the language server. But again, it's because they created TypeScript as a shim around C#. It was not created for JavaScript. It was created for C#. And then later, somewhere around version 3 or so, they kind of gave in and were like, oh, okay, well, we'll make it for JavaScript instead. And then they started supporting JavaScript types and stuff like that. But because of the heritage of the language, that it was kind of meant to be a standalone, incompatible language that happened to kind of be compatible if you squint and use very, very, very specific words about what you mean by superset and subset and that sort of thing. But yeah, it definitely wasn't. And we could go back to look at the types, and we could talk about TypeScript types versus JavaScript types and how they're fundamentally not compatible. Like I said, since the TypeScript checker version 5, the support for JavaScript native types has been really good. And then we want to exclude node modules. It's kind of like skip libcheck. Again, it doesn't actually work, but yeah, we get that. Okay, so if you want to run the type checker, boom, this is what you do. So ostensibly, if we run the type checker right now, we shouldn't get any errors. Oh, but we do. Of course we do. Because the node types are not installed. So let me go ahead and install the node types, and then let's see if we can run, because the tests run in node. Okay, so now we have no type errors. Now, let me go ahead and I can't, that won't work because of the way this is. Okay, so let's go into the next file, import map.html. This file is generated just for you to have a look at what this looks like. Oops, what? I could have sworn that I had fixed that in the latest version. So I had copied and pasted from a template that I had, and this was the template that I had at the moment, and this was supposed to get retemplated out with the name of the package, so this should have gotten retemplated out like this. I may just have on this computer, npm or npx sometimes grabs the wrong versions, and it's hard to tell it to get the right version. I'm pretty sure I had fixed this a while ago. I will have to go back and double check. But anyway, this is what this could look like. And you'll notice the syntax is different here. There's no asterisks here. There's no asterisks here. But that's what it needs to look like in HTML for your import map. Notice script type import map. This is a standard thing. And then after this, if this was my index.html file, I could do something like import demo from demo. Like that. Actually, I would do a capital D. So I could do that, and then in mine, I normally have something called UI or something like that, and so I'll do a var UI equals var because it's a global variable. And then that right there, or I could do window.ui, actually I think, or global this.ui, I don't remember. But that allows me to access UI in forms. Probably done it a couple different ways, but that allows me to, up here, if I have a form, then I can do submit equals, and then, typically I put these with a $sign on them so that I know that they're DOM, actually that's not how I do it. No, I do it like this. So submit contact info, like this. So this is what I'll do. So that way it preserves the event. I put the $sign there to denote that this is something that's operating with the DOM. It's going to get a DOM event. It needs to consider the DOM constraints, something like that.
What was the rule of thumb of when you do import star as versus just the default export name?
So we'll get to that in a second. When we get to that in a minute. Let me actually see npx JSWT - version. Will this do 2.2? What are we at? npm info JSWT. Pretty sure we're beyond that. Yeah, we're like 2.0.5 or something. Let me see if I can get npx to do this. Oops. I think we're past 2.0.3, but we'll see. I'm going to just delete that import map file and rerun it. So it shouldn't overwrite things that exist. But if something doesn't exist and it creates it, then it should recreate it. So let's see if it didn't do it. All right, well, I could just bomb the whole thing. So I'm just going to bomb the whole package real quick. All right, what have we got left here? Package lock, we'll get rid of that. Tests, typings, do we have anything in here? No, okay, so with that, let me just run this again. I'll do the npm init-y again, and the JSWT init, and let's see. Yeah, because I don't want to be going over the oopsies. Yeah, okay, see, now this generated correctly. Because I deleted that file, and this also had the example of local storage in there before, but it doesn't now. Okay, so there's that. And then, all right, so in the package.json, so here you can see type is module. Files, we have the files that we want to include. This prevents us from accidentally packaging up env files or config files or anything like that. I always have that there. Imports, so this is a little bit weird because imports works kind of like you'd expect. Exports but imports are internal. So imports are saying when internal to this package, I import from demo grab./demo.js. When internal to this package, I import demo/import from /. So again, you'll notice this does not have the stars. However, exports is the way that when another package imports this package, how it's referenced. And the dot represents the name of the package. So the dot takes the place of the name. So it's functionally the same as this, but the syntax is different. So we have imports, exports, import map, and whatever it was called in jsconfig.json. So it's a little wonky donk. But again, this is why I created the tool. I didn't create the tool because it's like, oh, look how great my tool is. I created the tool because I either have to teach you these 15 very, very slightly different things, and to get them right, that your NPM init isn't going to do for you, or you're just realistically never going to be able to get onboarded into JavaScript with types, because the figuring out the syntax for these 3 different files is just heinous. And then we've got this thing here, TSC. So you'll notice that I do not, we got stream boob wants to give us the best viewers. Oh crap, I accidentally clicked the wrong button. Now they're gone forever.
Viewers.
So anyway, what I was saying here is that you'll see that I have the not in front. Now, unfortunately, this is only going to work in POSIX systems. It's probably not going to work on Windows unless it's running from WSL. But this negates, it works. It does the right thing. But what this does is it runs the TypeScript checker against the jsconfig.js, and then it checks to see if any of the lines contain error, and then it excludes the lines that contain node modules. So a bit of a pain in the butt, but what this results in is that the output you get is only the errors that are in your code, and the pass-fail status results what's in your code. Because without this thing here, what will happen is if there's a type error in a package you depend on, then when you push this to CI, and it runs the type checker, it will fail. And that sucks, and that makes it kind of useless. And I don't know how other people get around that. Probably because in TypeScript you don't have to specify so many config options and more things work by default than when you're doing the jsconfig.json route. I don't know. I don't know how people get around that. But this is how I get around it. And this is designed primarily to work with the CI stuff. Then there's some other stuff that happens. It does include a type re-exporter, so there's certain cases where basically you need to re-export all of your types to index.js, so that when somebody imports your file, the types come in with the initial import and they don't have to dig down several layers into the other imports. So what this re-export does is when you run npm install after or npm publish, before it does that, it'll actually go and re-export all the types so that the types are up to date with the package that gets published. So yeah, I probably should have started with the example of how you use this rather than all of the edge cases, but oops, we've done messed up now. I don't know how the Undici types got in there. That's weird. Anyway, what else are we going to do? So yeah, so that's the thing. And now we finally get to the meat of this. So here, this is something that needs to happen. I actually have not fixed this yet, but I'm going to get this to auto-generate as well. So you need to do, let answer equals. So this is how you make it compatible with both NPM and ESM. So export default, this is for ESM, and export let answer equals demo.answer, this is for NPM. And because this is really weird, I don't know how they decided to standardize it this way, but the way that they decided to standardize it was that export default would only work for ESM packages. If you require a package that exports default, then it has the opposite behavior, where it wraps the export in a object called default. And then you have to do require demo.default. Well, if you were to update a package and publish the new version to NPM, you would break everyone who depends on that package. So what needs to be done for the sake of NPM, where predominantly people are still using require, is that you need to export every property that is a public property of the default object individually. So kind of a pain in the butt, but this prevents you from having that problem where you are, a lot of people try to work around this by creating names that stutter. So they'll have a person package and then they'll have a person dot create person, but then they don't want to have person dot create person. So then they export it as create person, or heaven forbid, just create. And then you have to alias it from create to create person and so on and so forth and blah, blah, blah. So that's how we get around that. Also, I'll just do another example real quick. If they have exported it for NPM, and this is the other kicker, is that packages that are published to NPM export correctly. You don't have to do the weird wonkadoo that I'm about to show you. But packages that are published to NPM to support NPM, then you have to do a weird hackadoo for ESM. So if you don't have the hackadoo, then you have to do this: import star as demo from demo. But what you want to be able to do is just import demo from demo. And I think, what was there, was it, I've actually been, is this syntax correct? Yeah, this syntax is correct. So anyway, so these are the two ways to import package. If one doesn't work, just use the other one. That's just an issue with ESM and the way that it's not the standard of ESM that's the problem. It's the way that they chose to interop with Node, and I think that actually lies on the Node committee, the OpenJS Foundation or whatever. I think that is their fault. And I think that there are reasons that they standardized it this way. I just think it was the wrong choice. I think the trade-offs are bad. Because if they had standardized it the other way, then what would happen is that people who create ESM packages that export in a weird way, those people, their packages would not be compatible and they would have to re-export them. But this makes perfect sense, because put the burden on the person who did it wrong. What they did instead was put the burden on everybody who did it right. And that makes it inconsistent, because in one the default is the default and the other the default is not the default. But then if you do the explicit exports in the one, then it's no longer the default export in the other, even though it's the default in the one. And yeah, so I think it was the wrong trade-offs, but I think this is also part because import, like I said, was not standardized until December of 2024, and it is now March of 2025. So it's only been standardized for 4 months, or sorry, it was standardized before then. It's only been implemented for 4 months in LTS Node. So it was implemented in Bleeding Edge Node 1 year ago, almost to the day. But it was not implemented in LTS Long-Term Support Stable Node until December. It was hidden behind an experimental flag. But anyway, my point is that people have been writing transpilers for ESM for about a decade, and so obviously when you've got all that baggage of all the incorrect implementations, and then you're trying to shim between the actual standard and the way that you had been doing it, crap comes up. Anyway, so none of that was the good stuff about the types, but we're going to get to the good stuff about the types. So I can do this. I can do @param number. Well, actually, in this case, I would just use @type, sorry, because I'm not defining the struct type, I'm defining the property type. So I can do this. And then I can also do, this is actually something I like to do, like I was saying before, I'll actually put it up here. So I can do type. So whenever you use curly braces, that's when you're consuming a type. And then when you're not using curly braces, that's when you're creating a type. So I'm going to create the type, uint32. And I'm going to create a type uint16. And I'm going to create a type UN8. And I'm going to do big num, or big int, sorry. And I think there's still a bug in this where you have to use big int in lowercase. We'll see if that surfaces or not. It didn't right there, but that doesn't mean it won't somewhere else. So anyway, then I could say instead of number, I can use a type alias, and I could say I only want to allow this to be a UN16. Doesn't enforce any type checking. Oh, whoops, I didn't spell it consistently. I'm not sure if I want that to be caps or not. I might, it's just, this is one of those things where I've struggled. I haven't decided for myself which way I like to do it. And a few different files have done it different ways. But I can do that, right? So I can also type def. Let's just go through a couple of things I talked about. And then we'll have to wrap up. Okay, so I can type def. We're going to type def a partial person. So we can show this off. And a partial person has a property which is a string that's name. And if there was any particular constraints on this, like I said, let me just go ahead and do this the way that I like to do it. So here's string, and here's let's say base64 URL, right? And so we're going to have password. I want to say that password has got to be base64 URL encrypted. Everybody knows about base64 encryption, right? Keeps your password safe. So you can just, put it in the database, right?
Drop off the string.
Right
there.
Oh, whoops, I meant to put string there, sorry. I meant to have that there. Okay, but no, we don't put passwords in base64, people. Base64 is not encryption. It is an encoding. It is plain text. Unlike what the military would have you believe about their F-15 fighters, where they transport the source code encrypted as base64. That's not encryption. True story, I talked with somebody who worked on a fighter jet, and they were supposed to encrypt it, but instead they encoded it, and the thing that updates the firmware expects it, and so it's just that way. It's just that way. Don't tell the Russians. Okay, anyway, so we've got this partial person, and then I can create a partial complete person, and then we can define prop. What was this going to be? This was going to be a person. Okay, this may actually not work because we're going to have a type dependency here. So we'll see if this actually works or not. But we're gonna have a prop person that's spouse, and no, it's gonna have to be an ID, because what will happen is that things will get cast to an any, which is terrible because it actually turns out to be an explicit any. It doesn't count as an implicit any, but when it detects a loop, it just casts it as an any, and so then you don't get type checking, and you don't know you're not getting type checking. But so try not to create circular references to types. I could be mistaken about that. I hope that's not the way that it would work here, but I have had that problem in the past. So just to avoid that, I'm going to say that this is ID string. So I don't normally go this hardcore with the type aliases. I do with the numbers because I deal a lot with bytes and it ends up being important. And I do anytime it's an encoding. So base64 URL string, hex string, all those types of things. I type alias the crap out of those because it's helpful. It's really, really helpful. And sometimes I'll even do it with with BE for big Indian or little Indian, because some of the things I work in, that when they get encoded, they actually change Indianness, and that's killer. Anyway, so now we've got these two types, but we can join them together. And it doesn't matter it doesn't matter where you do the definition. It just matters that there's certain cases where having type dependencies becomes a problem. Okay, so now we could do this. So now we've taken partial person and partial complete person, and we've created a person. And also, I don't know why I did this. I normally follow the correct conventions. So there we go. That's how I would actually do it. I don't call it partial person. I call it person partial. Person partial. Because then you want things to lexicographically sort according to the type. So if you were to do a lexicographical sort of your type comments, you would want it to end up so that all of the person types were together, not all of the partial types were together. And in that case, this is probably, well, no, that's the way it should be. Okay, anyway, so we've got that. Was there anything else that I need to do there? No. So now I've got this person that is the mix-in or the union of both the person partial and the person complete partial. So now if I have a demo.create function and I say that this function needs to return a person, and then this needs to accept, let's say it needs to accept a ID string as spouse, and it needed to accept a name. What properties did we put there? Name. Whoops, sorry. So that would be a string. That's just an arbitrary string. That's name. And then we do, what do we call it? Base 64 URL string. That's a joke, everybody. That's a joke. Please don't do that at home for the password. Okay, so now we can go here and we can do P equals. And so here's an interesting thing to note, which I think is really important, because you see in a lot of code these days, people take ternaries to the hilt, and I will die on this hill. Ternaries are the devil's playground. If you want to have a rockin' good time, go ahead, but please don't take it to work. Drink responsibly at home. So I can do this. I can do this two ways. One is that I could try to fit everything in here right now and do 6 calculations in line. I'm not going to do that because I'm not a masochist. Oops, and this should be spouse ID. Sorry. So let's do spouse ID. Also, types I typically use Go/C# casing, depending. I goof up on it all the time, but I typically use the Go/C# style of casing, whereas values I use JavaScript casing. And I don't exactly know why, but I think if you program in Zig a little bit, you'd understand it, because Zig's got it right. Like Zig, properties are lowercase, functions are snake case, or the camel case. I don't remember what it is off the top of my head, but Zig has a convention that makes sense. I think that it's that classes, well, they don't have classes, but their structs, their type definitions are in title case. I think that their functions are in camel case, and their properties are in snake case. So you can tell by looking at the case of a thing, kind of like with Go, where Go has, I don't know that that's enforced by the compiler, but it is a really great thing, and I love it. Okay, anyway, so I could take these things and I could just pass them in like this. That would be fine. Obviously, I'm doing this for demonstration. We'd have more complex logic where we check something, yada yada yada, right? But okay, so you can do it this way. Let's see. Why is it grabbing? Name is implicit. Oh, whoops. Sorry, I did prop here because I was doing prop up here, and I just got in the prop mindset. When you are defining a function, it's not prop, it's param. So, boop, there we are. And then we can give this a nice thing, like creates a nice default person.
Precedent.
Yeah. And you can notice I have spell check turned on. There's a lot of things I need to add to my spell check, I guess, but you can see everything's underlined that's not caught by the spell checker. Anyway, so we've got this. This looks great. So what if we do this? What if we call it name X is name? By the way, here's another pro tip. Do one or the other, but don't do both. Don't mix and match default parameters and named parameters. Name your parameters or have default parameters, but be consistent in any particular expression. I'm not saying that throughout your whole program only use one or the other, although if somebody supports that style of consistency, I'm not going to argue against it. I'm in favor of it. It's not what I want to do myself, but I'd be happy to adopt it in a code base. But what we want to do here is, for the sake of our sanity, either use name parameters or don't. Name parameters meaning that we've got key values here, or default parameters meaning that it assumes the name of what it is, like this. Okay, so here, let's just look at a couple ways that this can type check. So right now we say that this returns a person. Okay, now what we could do is we could get rid of that, it returns a person, and now it's not going to complain because it's like, I didn't know that there's any type enforcement on here, but what we could do instead is we could say that P is type person, and then we'll still have the same return type, but now we get an error more specifically here. So now it's saying name X is not the kind of thing that exists. Okay, that's great. Okay, but check this out. Now, this one, so sorry, are there any questions up to this point with the types?
No, it's pretty good.
Okay, great. I'm glad that's understandable. Okay, so now we can do this a different way. Let's go back to how we had it before, like way back, before we messed that all up. Okay, so now we're back to the way that we had it before. Here's the third way to do that. So one way, have the returns. It'll check the return value, so it won't tell you where the assignment went wrong. So if you wanted to tell you where the assignment went wrong, you can put it there. But if we mess this up again, it will say, if I look at messages here, it's going to pop out and it's going to say property name is missing in type name X, blah, 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 but required in type person partial. Okay, so that was pretty helpful. But the other thing I was going to say is we can also do this, which is particularly important when things don't neatly fit in line. My rule is one expression per line. So I don't even do mathematical expressions that could be ambiguous in line. Like I'll do multiple additions in line, but the moment that a subtraction comes in, it's like, okay, let's just break it down, because that's one of those things where, adding a number that has been subtracted from, no, that's associative. It's with, anyway, there's cases where math is not associative, and adding a negative is more explicit than subtracting in terms of the results that you get when you combine mathematical operations. Anyway, that's not that's just a thing I recommend. Anyway, but you can do it this way. This is what I was going to say, is that you can do it this way, and then if you need to do a complex operation, like say, because normally we don't just do something like this. I mean, if it was this simple, we'd literally just create the object. We wouldn't have a function to create the object. But oftentimes we can't specify all the properties in the object and have it clean, because then we have to start resorting to ternaries or anonymous functions or start doing weird stuff to try to force it in line. React, people. Declarative. Freaking write a program in one line. Anyway, so this makes it much nicer, and the only thing that you have to do here is by the time you return it has to have all the properties. So if I get rid of this property here, now it fails. Now in TypeScript Checker 4, this did not work as nicely, because there are also times when you need to have some sort of block around something, like for whatever reason, the way you define it, like maybe it's an if statement where you have, like there's some reason that you have a block, and it wouldn't catch it. Now it does. So this type of thing right here used to cause an error because it would say spouse ID is not defined, but now it got smarter and now it can tell. So it's very, very good now at telling that the type has been completed before the return of the function. And that's what's important for the JIT, because the JIT needs to know when this thing returns, is it a struct that I'm creating or is it a map? How am I trying to optimize this? What am I trying to do? And the TypeScript checker is just much better at that now. So that's one of the things. One of the most unintuitive things is typing a function. So what I'm going to do here is we're actually going to strip this away. We're going to say that this is of type, and I don't know if this is going to let me do this or not. Person create. So you would think, okay, well, I'm creating a type, I'll just type def it, right? And I'm going to type def person create. Wait a minute, what's this error? Well, why is this not working? So type def can only be used for structs. Now, what's the next logical thing? You do a little Google, pardon my French, a little search, and you find function. And you're like, oh, this is right. What? Whoops. Let's see. Let's see if they fixed it. I have a bug open for this. I have it referenced in the slides. Cannot find name person create. Okay, let's double check the spelling here. Person create. What's going wrong? Here's a function. I've typed a function. I don't have an error about typing the function. Well, turns out that the TypeScript people have decided that I don't know why. In some contexts, and I have not discovered where function is useful. I have never found function to be useful. In order to declare a function type, you have to declare it as callback. And I brought this up in GitHub issues, and I said, hey, there's a bug. And they said, no, it's not a bug. A callback's a function. They're the same thing. And I was like, no, they're not, because a callback is a function that happens after the event loop execution, which is not most functions. Most functions, you call the function and you get a result. You don't have to wait for an event loop. So why would you call it a callback when a callback has a specific meaning in a very specific context that should not be misconstrued? And the person was like just playing dumb? I don't know. But they decided it's a won't fix or something. So I hope that one day other people comment on that issue and say, hey, this was really confusing and unintuitive. I would have never in a million years guessed that the reason that my type for my function was not generating an error and not working is because function is a dead alias that's a no-op, and callback is how to declare a synchronous function that executes within the current event loop cycle. But that's the thing. So
Do you think it had anything to do with the reserved word function in the parser?
I don't know. I mean, it's
Like that at function thing exists, right? It's just never used anywhere.
I don't know. I think that JSDoc declares it as function, and for whatever reason, the TypeScript people decided to implement callback, but not implement function, and I don't know why. Maybe there's some legacy incompatibility. I don't know why they won't just say either can be either. Callback is more specific semantically, but
If
function,
defining.
yes, but function is always correct syntactically. And in this case, function is callback is incorrect semantically, and function would be correct semantically. So, I don't know. But anyway, so there's how you create a struct, assign its properties, and this will be able to be JIT optimized because the JIT can look at this and it can determine that there is no variance in what this returns. It's always the same types. So it's all good. And then if you, there's a couple other things that I will mention. There are cases where you have to do or null or undefined. And then also this. So this occasionally happens. So the square brackets means not defined. So spouse ID is an option. It may or may not be defined. There are some cases where you actually need to pass in the value undefined. I mean, you could construct your function in a different way, but like, let's say that name were an optional property or spouse were an optional property. That actually makes a lot of sense. So we could go over to wherever spouse was, So this is going to be optional. Well, there's going to be places where in your code you don't want to check if the spouse property exists, call the function with only 3 parameters, or call the function with all 3 parameters, but if it doesn't exist, then call the function with 2 parameters. You just want to pass in all 3 things. Well, in that case, you are defining it. You are defining it as undefined, which is distinctly different from not defined. So that's this little nuance bit that comes into play. And so there are occasions typically, and also the shorthand syntax for null, ironically, or maybe not ironically, is it is the question mark. And I think that it just has to come before the closing brace. But that's the same as doing or null at the end. So the question mark, I think that this makes sense. I think that it's a good way to go about it. Except sometimes in this case, this looks confusing to me. So in this particular case, I often prefer to put the null here. But again, try not to mix and match. If you're going to use a type definition with question marks, then use it with question marks where you can. If you can't use a question mark, then just use or null so that it's consistent. But anyway, yeah, it's just an edge case that pops up from time to time where you have to include undefined in the list. So I wanted to make sure you know about it. And other than that, I mean, I could go on for another half hour just showing different examples of how to do types. But to me, this is like the 90%, and if you can grasp this and these edge cases and how this works, then you're gonna do pretty well. The one other thing that I'll show is, let's say we wanted to create a value enum. You can mix and match enums. You can do all sorts of stuff. In fact, for documentation, I'll sometimes do stuff like this, like I'm about to show you. Okay, so secret and super secret. This is probably going to generate an error because password is defined elsewhere as having to be, no, it's not, because it's only a type alias. It's not a new type, although I would like to learn how to make the new types. But anyway, so you've got this here. So this will now only allow me to call this function with the types. Oh yeah, so this is saying, yes. So this is saying that this is not assignable to string. So it is giving me the error. But for completeness, let me just show demo.create. Name is AJ, password is bananas, and spouse ID is 123. Okay, now, whoops, and I should probably do let p equals. So now you can see that it's upset about bananas because bananas is not in the strict set of either secret or super secret. So for documentation purposes, sometimes I will do this because I want the documentation to show this is what the value should be, but I don't want to enforce the strict typing where, okay, I'm getting some JSON, the JSON API is already defining it this way. I don't want to have to go through a complex process to say, trust me, bro, I know the string is either secret or super secret. So sometimes I'll do this, which of course causes us to lose that type check that it's one of those 2 strings. So probably not the best thing to do, but there's a lot of cases where, you're working with maybe 2 or 3 different packages and you're like, oh, actually, we do need this other value to be there. And it's like, I don't want to go update that package right now. I want to finish this unit of work, get this PR through. Then I'll go update the other package to make sure that the types are consistent. So that's an escape hatch that I use. I don't advocate for it. I'm just letting you know because if things get too congested, if it feels too icky, then you get the ick. And if you get the ick, then you throw the baby out with the bathwater. And so sometimes the shortcuts, they're good for our development cycle. I'd encourage you, of course, to be responsible and go back and fix that. I don't use any, except for in some very rare cases. where it literally doesn't matter, where it's like I'm literally just doing a connector, where it's like I'm connecting this piece to this piece, and it's like what this thing is doesn't matter to this function at all. In a few cases like that, I'll throw an any in there, but I don't use an any as an escape hatch. One of the escape hatches you can use if you need an escape hatch, which will pop up in the linting process, is you can use unknown. So this will allow you to define a type. It's kind of like a to-do for the type as opposed to any, which is like a look the other way. Unknown is more like a to-do in the way that it functions. It'll pop up with errors in some cases. Last thing I wanted to cover was gonna be the template type. That's one thing that I think is really, really useful and really important to cover, so I'll cover that. So this is gonna be base64 URL string. Dang it. Yes. Yeah, there we go. Okay. Let the autocomplete do its job. All right, what is this griping about? Not assignable to type string, type person, password, bananas. Hold on. What is it griping? Okay. Oh, it's saying that null or undefined is not compatible with. There we go. So yeah, that's exactly what it was saying earlier. So we could do this, and say that this can be null. Okay, and now that goes away. So depending on how you declare it, sometimes you have to do the undefined, and other times it's fine if you don't. So undefined versus not defined is one of those nasty type cases it's just tedious and stupid, because semantically there's no difference, but if you're iterating over an object, there can be a difference. So it kind of makes sense for the type check to be there, but and there are some, like JSON.stringify will just elide away the undefined. So if you have keys that are undefined, you don't have to worry about it. However, other stringify functions, such as URL to string, does not elide away undefined, which I think was very poor oversight, because it was standardized well after JSON.stringify was standardized, like a decade after. So I don't know why they made that choice, because I think the stringifying undefined as empty was the right choice. Especially these little nuanced details are just stupid. You don't want to have to deal with them. But, okay, so last thing, we're going to create a sort by function. So we're going to do demo.sort, sort by name equals function. And then, actually what I normally do is I call it, so we'll do at type def has name, and then I'll just do at prop string name. And if you want, for documentation purposes, you could do pick person name. So for documentation purposes, you can do, you can do this. Is that right? What did I get wrong? Pick key, oh no, sorry, is it this way? I always have to look this one up. There's a couple of these where the key versus property is not statify the constraint. Okay, pick. All right, I'm not going to do it. You can go look up the documentation for it, but it's something like this where you can say pick the property of this thing. So because we could just say string, and in this case, semantically and syntactically, that makes sense. This is not unclear. But in cases where it is unclear, it's sometimes helpful to do the pick this thing of this thing, so that it's more clear. Like, for example, there could be two things that have a name, but they have semantically different meanings, like the name of a person versus the name of a class. like they're semantically different. They're not quite the same. So there's some cases where you might want to document that. I probably gave a bad example, but I hope that the point stands clear. So then in this, what we can do is we can do @template t has name, and then we can take in named, and then I guess we just call it A and B. So then we have @prop T A T B, and then we could return A.name is less than B.name. Oh, sorry, not prop param. So I did the same thing but backwards this time, or maybe it was the same way. The funny thing is in JavaScript, you can have a function that has both params that it receives, but it can also have properties. So I could do @prop. I'm just going to be silly here. We're going to go UN8 version. So the version of the function. Now, type checker should fail. Okay, it did not. So the type checker failed me. But the function person create can have a property version. So that would look like this. Apparently it's not being checked here. I thought that I had this work before, but we could do something like that. And that's weird to me. Maybe properties have to be defined before params are defined. Let me try that. Nope. Okay. Well, that's not working right now, and I don't know why, but that is syntactically valid in JavaScript. But it's okay. I don't recommend doing that. I don't do that in my code. I've only done that when I'm taking legacy code and I'm bringing it forward. Because I always do defaults, always do exports as an object, because you don't have, you can avoid, if you have to have a circular reference because you architected something poorly, you can get around that if you're exporting an object, because you can add the properties at a later time and have the type complete. There's other things that just exporting an object makes more sense. Then you get a package, importing demo from demo, not importing do stuff from demo. Like that just doesn't feel right. Or anyway. Okay, and then here, okay, name does not exist on type T. So I am doing this wrong. Let me try template has name. This is one of the ones where I use it every now and then. Okay, is it this way? All right, so now if I do name X, if I misspell it, we should get an error. Yep, we do. And then if I do it right, it should be right. Okay, so this is what it looks like. So template is a type def. So we're consuming has name and we're producing T, and then we're allowed to use T here. And so now both A and B are of type T, which means they both have a name. Obviously, this doesn't matter in this case, because I could just pass, in this particular case, let me come up with a better one. Let's say truncate name. So truncate name, if I do truncate name and then I return A, and let me move this over, we're going to do this slightly differently. So we're going to retain another function. Boop, boop, boop. Demo dot sort by name. A, B. Okay, and then we're just going to return A.name minus, less than, and this is obviously not correct, but because we need the equal condition as well. But we're just going to go param has name. What did I do wrong? Has name param. Has name A, has name B. What did I do wrong here?
Is it callback as has name?
No, because we're not defining the type for it. We're defining it in line. So has name. We're going to ignore that. This is just because my eyes are something else is off. Okay, so if we do a.name equals, we're just going to truncate the name entirely, and we're going to get rid of this here, and yeah, we'll get rid of that. Okay, so what would happen if we didn't use a template here? If we just did hasName, it would accept hasName for this. But what would happen is that it would return hasName as the type. But when we use the template, that means that it's still going to return person as the type if we put in person, or it's going to return dog as the type if we put in dog. So that's what that does. And there's, oh, I know what's wrong here. I know what's wrong here. There we go. I was missing that. So with the sort by name, since we're not returning, we're not changing the type of the thing. We're just saying we accept anything that matches this type interface essentially. And then up here, I could show this. Where did our P go? I'll show this and then let's call it a night.
My wife is like, "Where are you?"
I'm so sorry. I got on a roll. What can I say?
So those docbox definitely have to have the double star opening for the parsing.
Okay, truncate name P. Console.log P1. Okay, so let's actually do one better. Let's say we're going to we're going to be kind, so we're going to do object.assign, and then we're going to do name a like this and return the dupe. This way, it's immutable. So, whoops, actually, I think we wanted to do it the other way. Let me do it the other way. So object.assign is syntactically how you create new types at runtime, both in the JIT and also the way that TypeScript checker understands it. So anyway, so now we have this thing, and so what I've done is I've taken, oh, this isn't gonna, yeah, okay, this is gonna match. Okay, so I'm taking an empty object, I'm duplicating it with the properties of A, but I'm overriding name. And in fact, the way that this looks a little weird, so I'm just going to clean this up even though this is only a demo. So dupe.name equals this. All right? So we copied all the properties of A onto a new object, so we've created a new object with a new type. We've assigned it name, we're returning dupe. Now because we're saying template type T, it's just going to pass along the type of A to the type of dupe. And we don't have any error. But now let's reverse this. And we're going to say, I'm just going to comment this out and comment this out for a moment. And we're going to do @param hasName. Now it's going to lose the type information for A. And this is going to complain if I access password. Okay, see how it's, password does not exist on type hasName. It lost its type because of this function I had created that creates a duplicate of it. But now, if I go back to using the template, error goes away.
It's the generics of it all, right?
Yeah, yeah. Anyway, so I hope you found that enlightening.
Very much. I mean, personally, my opinion on TypeScript has changed. I mean, I was a JavaScript user until I went to Remix meetups, and then they convinced me for TypeScript. But I think this completely changes my opinion on it. It does get a little bit of getting used to and kind of using it, but I can definitely see it being used on a big project. I guess, to be honest, TypeScript was not needed if this was developed in a more stronger way. Like, I mean, you did this.
If the tooling was important.
Yeah, so I had to read from other people's blogs. Like, I think it was Gil Gad was one of the people who had first discovered how to do this. But yes, it took me months to figure out how to get it to work. Once I got it working, it's great. And yeah, And if you go to, like, here we've talked about the ESM version. If you go to this presentation is pre-ESM, so there are some things that are different if you go to jswithtypes.com. But, if you want to see the presentation or just scroll through the slides, and the reason I did the slides this way is so you can do Control F and look for something like template. This is something I haven't liked about other slide tools. And so I had to fix it for myself. Let's make that nav go away, actually. Okay, nav goes away, and then template. Okay, there we go. So I wanted the slides to, and this is not how I originally presented the slides. The way I originally presented the slides was with a common tool. But it's like, I need something that's in between slides and a blog where it's like, okay, if I need to go find, where did I reference that thing? I can go find it. So you can search through the slides if you want to. Unfortunately, I couldn't figure out how to get the scaling to work, so it's like way off. I did at one point have everything right, but CSS, it's still like 30 years behind the curve. So there's things that they just introduced into the standard. I was like, oh, finally we can do scaled divs, and it worked until I wrapped it in another div or something, and then the text all got 3 times smaller, and then everything else got 5 times bigger, and between VW and REM and a couple of other things. I've got a buddy who says that he's figured out how to do this with CSS in a non-hacky way, but he wasn't able to find where he had done it. And so we haven't retrofit this yet. But anyway, point is, the presentations here, the slides are more up to date than the presentation is because I did this presentation again. Also, you can see the previous iteration of this presentation on the Utah.js channel. So you've got resources if you want them. And I hope that it helps you, and feel free to reach out to me. You're in the Discord, right?
No.
Oh, well then join the Discord.
Well, yeah, someone posted a comment on that on the under the meetup, but no one ended up responding yet. So I was hoping to get that when I come in here for today.
All right. Okay, well, I'm going to go ahead and stop the stream. Thanks for tuning in if you tuned in. Like, sub, follow if you want to. Catch you later. Adios. Oh, and the end.